everyone. Thanks for coming out tonight to the Marys River Watershed Council Tap Talk series. We'd like to give a big thanks to Common Fields for hosting us and for generously donating a portion of tonight's sales to the Marys River Watershed Council. And so, grab a drink and tip your bartender, and thanks for coming out. We'd also like to give a thanks to the Oregon Conservation and Recreation Fund for their support in helping to make these Tap Talks possible. Tonight's talk, we have James Cassidy here with us. James is an instructor of soil science at Oregon State University and has been for over 20 years. His introductory class has over 100 students each term and is very popular. And James is also a faculty advisor for the wildly popular OSU Growers Club. Organic Growers Club. Which is OSU's student farm. Coming from a non-traditional background in the music industry for over 40 plus years, he is passionate about soil. And is popular with students because of his dynamic speaking style. The Student Farm Project has over 300 student volunteers on its listserv and continues to grow. And the farm cultivates over 50 different fruit and vegetable crops and is just beginning its 24th season. So I'll let James take it away.
Thank you so much. Thank you so much for the introduction. Nice to see you, friendly crowd, half drunk. Not yet. And thanks a lot. And thanks to the Marys River Watershed Council. Come on, let's hear it for them. For sponsoring these, you know. Yeah, my name is James Cassidy. I'm a senior instructor 2. So at the top of my pay scale. No more promotions. Don't ever get a promotion. Because all it means is you're not getting rewarded for the work you've done. You're signing on for more work. I had to learn that twice. Anyway, so, and I'm the founder of the OSU Organic Growers Club, the student farm at OSU. 24 years ago, 3 students complained that there was no organic anything in any of their education at Oregon State University. In fact, it was very hostile to the idea, which is, 24 years ago, it was not that long ago. And so they said, well, let's start our own damn farm. And I said, sure. So I went to their first meeting, and they're all gone. I don't even know, actually, I don't even know, I only know where one of them is still. And they all graduated, and I stuck around, and I turned it into a little career here, actually. And actually, when we first started, they tried to throw us off the farm because, what are those kids doing out there? They're growing weeds and probably smoking weed, and what's going on out there? And and so we just kept coming back. Trying to throw us off 3 times. Just kept coming back, and all those people who tried to get rid of us are either retired or dead. Yeah, man. So all I got to do is just wait. You're next. So, okay. Sooner or later, you're the man. So I just stuck with it and have been running the student farm for 24 years now, which is now officially a nonprofit. It has always been a nonprofit, but we're officially a nonprofit now. But I shouldn't even tell you this really, but it was all cash for 20 years. And we sell all this stuff. And that's how we fund the project. We get no support from the university other than they don't throw us off the land anymore, which is, something. And it's all right. In fact, the dean is now a customer. So, And actually, I'm meeting with the new president to show her a little plot over at Oak Creek next week. So, see how it works? you just subsume them like an amoeba. Anyway, so we sell the vegetables. We have a CSA program. And we're accepting customers right now, and that all the money really goes to just paying our summer intern crew. But like I said, it used to be cash. I literally had cryovac blocks of $1,000 cubes behind my pictures in my office. And then at the winter meeting, I would hand out to the interns that here's your $1,000 in a cube. And I just want you to know that door money, a little bit dirty, $1 weighs a gram. So you can just weigh it. You can just weigh the money. And I counted it, but I checked it on the scale. If it agreed with the scale, I called it twice, and it was good. Anyway, so yeah, I run. I grow these kind of. This is like a typical CSA box in, like, say, late August or something like that. And every week we do that. So every week you get these vegetables, and they're just beautiful. The fruit is certified organic. We all use organic methods. And anyway, but I can tell you all about that stuff forever. Believe me, I can talk a long time. How long am I talking?
Keep going.
Okay, okay, we're keep going. Very good. I'm also the former president of the Oregon Society of Soil Scientists. So I have a lot of credibility. Anyway, blah, blah, blah. Yeah, soil. It's all about soil, though.
Yeah, soil.
All right. Right on, man. How's it going, Pat? I sell those stickers, too, to pay for the cans. And that's how we do it. So we sell the vegetables, and then we extract the value from the land. Where does all value come from? Land and labor, and the rest is trade and theft. And just know the difference, right? And there's a lot of theft, right? So that's how. Not in our group, though. We're nonprofit. We're officially nonprofit. We're now, however, we don't have cash bundles in my office anymore. I never wanted to ask, what am I going to do with the money? Because I figured they'd say, you can't do that. And then it got to be like 20 years later, and they would have said, how long have you been doing that? You're fired. And so I just finally asked somebody in confidence, what am I supposed to do? And they said, it's super easy. You just get an Ag Research Foundation fund, and then you're automatically a nonprofit. So we're officially a nonprofit now.
So can you accept donations?
I can accept cash donations, cryovac, $1,000.
You're a 501c3.
Yeah, we can take that. Yeah, and we have a website where you can just swipe and everything. So that's really.
What's the website?
It's called soilforward.org. Soilforward.org. All right, and more on that later.
Can you buy the t-shirts there?
Well, we're getting to that. That's my closer. Anyway, thanks. So anyway, it's all about soil. Can you hear me? Can you hear me in here? Yeah. I mean, and I don't just mean like growing vegetables and like, agriculture and stuff. I mean all of it. Every atom in your body. My goal, by the way, tonight is to change the way you see reality. Okay? That's where we're going. Are you ready? If you don't want to change reality, there's the door. If you like the way things are going, fine, get out. So it's all, every atom in your body has been through the soil system billions of times already. The fact that you are not soil at this moment is a temporary condition. And really temporary. Look, folks, it's almost over.
Some of us are closer to
Yeah, I know. I mean, it's almost over for all of us, actually, okay? It really is. I mean, what is it? 70, 80, 90 years? Maybe 98 with your ex-husband or your husband who passed away last year? Gone? Oh, sorry. And that's just nothing. I mean, so even if you lived at 100 years, that's nothing in a planet that's 4.5 billion years old. I mean, come on, you're not even here.
Right.
I mean, you're just a ghost. You're just like, mostly your soil. And you're, hey, this is pretty cool. Before you know it, it's like, before you can even say, hey, this is pretty cool, it's over. And yet, here we are, all together here tonight, in this room, in this time in the history of the cosmos. We are here together at a time when we know things that we didn't know even 100 years ago. I mean, it's a miracle, right? I mean, you want a miracle, here it is, just us here together right now. Yeah, Marys River Watershed Council. Yeah, making it happen. We brought it together. And I mean, And actually, every atom in your body has been through 4 supernova already. Yeah, I mean, our sun only has enough energy in it to make hydrogen and helium. Where do the other 118 elements come from, or 116? Right? They came from supernova. And why that's there, nobody really knows. So you work on that yourself. But everything in this room, everything you will ever see, everything you've ever seen, every person you've ever met, everything is made out of these 118 elements in the periodic table. That's what it's made out of. And all those things are actually mostly in rocks. And rocks dissolve into water. Maybe you've never thought about that before, because you only live 90 years. So you never saw a rock dissolve in water, but they dissolve really rapidly, actually. And what dissolves out of them are nutrients. That's what nutrients are. Calcium, phosphorus, potassium, blah, blah, it's just dissolved out of rocks, right? And so rocks dissolve in water, and that's what the nutrients are. And then plants take them up, and plants have figured out a way to use the energy of the sun to capture the energy from the sun and eat the atmosphere and take up the mineral nutrients and make this, and then you eat it, and that's how it got into you. Every atom in your body went through that process, and every atom in your body, sooner or later, and pretty darn soon, is going back where it all came from. That's a fact. Yeah, those are facts. Yeah, this building, this great building, sooner or later it's going to burn down, or they're going to tear it down. So it's just going to go back into it. You know, there'll be a giant ass flood again. I mean, it's just gone. Won't be long. So for this moment tonight, here we are. Celebrate. Let's get it up there, Holmes. Come on. Celebrate. Good times. Come on. Delicious. I love Tap Talks. Super friendly. But, so I mean, I don't know. I brought some soil in here. Look at that. Right from outside there. Look at that. Great demo, I know, but you've seen it before. Look, it's alive, right? I mean, I don't know if you know this, but in a single pinch of soil, this soil, which I just got from the garden right around the corner there, in the single pinch of soil, there are over 1 billion living organisms in here right now, representing representing tens of thousands of species in here right now. 99.99% of which we don't know who they are or what they're doing. We know they're there, we can measure that. We know they're there now. 100 years ago, nobody could have believed that because you can't see it. And people used to not believe in CO2 because why would you? You know, right? Some people don't, I'm sure. Probably even in this room. There's the door. But yeah, I mean, this is by every measure what it is habitat. By any measure, soil is the most diverse habitat on the planet Earth by any measure, by numbers, sheer numbers, by mass, by diversity of organisms. This is really, really where every biological chemical reaction that's happening, biochemical reaction happening in your body right now, happened here first with the bacteria and the fungi that lived here. I mean, I would argue that you too. Look at that. I would argue that you are soil now. You're a 4-dimensional complex habitat, self-organized natural body, a living thing. And that's right. That's what soil is. Same thing, same exact stuff. Just organized differently, but not that much differently. And these billions in a single pinch, I mean, what they are is they're like our external metabolism. They're like eating, they're breaking stuff down. Where is all the dead stuff? I mean, why aren't we like 14 miles high and dead giraffes? You know, where do they all go? They're rotted back to the ground, because that's what these guys are just waiting for stuff to die. You know what I'm saying? And it won't be long now. I don't mean this talk is not almost over. Your life is almost over. And actually, you won't be eaten from the outside in. They're already in you. I mean, 80% of your body by dry weight isn't made from human DNA. You are a habitat. There are nematodes that live in the sockets of your eyelashes. I mean, there are amoeba that live down in the sockets of your teeth that come up and eat the protein deposits of your teeth at night. I mean, what's going on in your shoes right now? I mean, really. And just think, and like in your gut, look, there's a hole here and there's a hole here, and there's a tube going through your body. And it's the outside world that's inside of you in a tube. The soil is in there. The same bugs that are in here are in there. And what you're doing is you're feeding them. And then they ooze out enzymes which dissolve the organic matter, which release the nutrients that goes through the cell walls into the bloodstream and get pumped to every cell in your body. And with the energy of the sun, of your beating heart, from the energy from the carbon-to-carbon bonds, from the carbohydrates that were formed by plants that lived in soil, and everything else is a sideshow. All there is there's a sun, and that rocks dissolve in water, and there's water, and there's rocks, and that's it. And everything else just flows from that basic physics of that. And physics begets chemistry, and chemistry begets biology, but it's all about physics, right? So, I don't know if I'm going too far here, but too bad. Look, I'm going to go further than that. Look, I have a rock right here. Thank you. There's a rock. Look at it, cozy up to a rock tonight. And just have a look at it. You know, take a bong rip and like check it out and look at it. And what it is just a collection of elements. It's just chemical. It's just chemicals. And different colored rocks are made from different minerals, and the minerals are the individual crystals in there, and those crystals can be large or small depending on the rate at which it cooled and blah, blah, blah. And different colored rocks have different elements in the crystals, in the minerals, and when they dissolve, they release those mineral nutrients, and that is kind of the inherent potential fertility of a soil that forms from it. And so that's why there's different, I don't know if you know this, but there's 20,000 different named soils, at least according to the USDA. And that's because they're different. They form from different rocks, they from different climates, different topographies, and there's the soil forming factors. What is it? Say it, man, say that. Say chlorped. Climate, organisms, release, parent material, time. Those are the 5 soil forming factors. And those factors determine what kind of soils are where. And different soils are in different places for those reasons. So when these things, and if you don't believe me, if you don't believe me that rocks dissolve in water, watch this. See that? Look.
It's almost gone.
It's almost gone, man. It's a tiny bit of that dissolving in there right now. And if you still don't believe me, I mean, maybe you don't know this, but the first thing to dissolve out of you just take a little bit of table salt, sodium chloride, 2 elements, right? And ionic bonds, and you put them in water, you put a little on your hand, and lick it. And that is a mineral that dissolves very fast. And some minerals dissolve fast, and some minerals dissolve slow. And the next thing to dissolve out is the calcium and the phosphorus and the potassium and the cobalt, and hopefully not the cobalt, but the molybdenum, right? And everything else. And the last thing to dissolve out, which doesn't dissolve out very much at all, is the silicon dioxide, which is sand, quartz. And so all these minerals are dissolving out at different rates based on what they're made out of, and those are what the nutrients are. And the different colored rocks determine the nutrients that are available from the soil, and that's why there's different kinds of plants and different kinds of animals in different parts of the world because of that. But think about it. Right now, what's the first thing that dissolves out of a rock? Salts. Salts dissolve out first, right? And then you can taste it. It's delicious. But think about it. So if I just take I'm not going to do that. But if there's a little salt in here right now. Look, tiny bit of salt dissolved on that rock. Someone down on that floor there. And that's going to dry there. And they're going to mop it up sooner or later. Or it's going to get down into a crack here, and it'll just be there until this place burns down or they tear it down. And then the rain's going to fall on it. Or they're going to squeegee out the mop water sooner or later and dump it out there. Or put it in the drain, whatever. And where's that little bit of salt going to go? It's going to go down in the soil. And every time it rains, it goes a little deeper. Then it dries out and becomes a little crystal. It goes a little deeper next year. It goes a little deeper. And pretty soon it gets down to the water table. And then the water table is connected to the little creek right over here, which is connected to the big creek, which goes into the big river, which goes into the giant river, which goes into the ocean. And that's why the oceans are salty. Yeah. And what's next that comes out? The molybdenum, the potassium, the phosphorus. Where does that all go? Out into the ocean, and that's why there's sharks. Because the nutrients dissolve out of the rocks.
Megalodon.
And that too. And that's the new one?
That's the
Yeah,
new
man.
one,
Yeah, man.
Big.
Right. And they end up, and all those nutrients end up in the ocean. And when they're out there in the ocean, think about it though, they're totally dispersed in this giant body of water. And so they're not collected anywhere. So it has to be these tiny organisms that float in the water, these phytoplankton that use energy from the sun, and they collect it, and they make little shells, and they do the thing, and they make the biochemistry, blah, 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 and they live, and then they die, right, sooner or later. And then, or they get eaten by a zooplankton, which gets eaten by little fish, which gets eaten by a bigger fish, which gets eaten by a shark. And that's why there's life in the ocean, is because rocks dissolve in water, and the nutrients end up in the ocean sooner or later. Right? Sooner or later, every atom in your body, sooner or later is going to end up in the ocean, as it has already done before, maybe many times over. And so there's your nutrient cycle. Actually, the large nutrient cycle is uplifted marine sediments that become landscapes like this. And then that all dissolves out again and goes back into the ocean. It goes around like that. So what soil is a four-dimensional complex habitat of self-organized natural body. But what it really is it's somewhere between all of the nutrients being locked up in a rock, which aren't available to us or life, and complete dissolution in the ocean. And somewhere between there is this moment where the rocks are sort of falling apart, but they're still around, and they're dissolving out, and they're releasing nutrients, which get kind of captured in the surface soil, in the surface layers for various reasons, long enough and in concentrations large enough that macroorganisms can evolve on the planet Earth, which is really different than being completely dispersed in the ocean or locked up in a rock. And that's why you're here. That's why you're here. And that's why you're here. And those are facts. That's the truth. It's all about soil. And sooner or later, I mean, it's almost over, folks. I don't mean this talk. It's all going back to the soil. So don't worry about it. Really, God, you know what? Everything is exactly as it should be in the soil. Even that screwed up soil, whatever. This is nothing. I mean, the planet has seen massive asteroid impacts, planetary collisions, and life goes on. It's just us. We're toast. That's all. So everything's fine. Just relax. So just a little bit, just once in a while, say, what are you going to do? Do what you can. And that's it. You can't sacrifice your whole life. I'm doing it, but I'm doing it for you. I'm sacrificing my life to be here tonight. But so what is soil? Soil is dissolved rocks that release nutrients, and it gets stored, and so there's this other thing we got to talk about, and that's what plants are. Now we're going to get to the slides. I mean, who wants to get the slides? But slides will be good once we actually talk about reality here for a little bit. So I don't know. We don't have to look at this. Look at this. This was once a tree here. This barrel is made from oak trees, probably in France, maybe in America, or Hungary, or something.
White oak from Oregon.
Is this white oak from Oregon? A plus. All right, hang on. Hold on. Here we go. That's a ticket to Love's Labor Lost. That already happened. Here we go. How about a gold star for you? Yeah, man. Where do you want that? There you go, babe. I'll put it right there, man. Yeah, look at that. Yeah, man. All right, see that? This is why you do it. Yeah, man, it's all about glory. And only teachers can get these. I don't know if you know that. Can't buy them, you have to have a license. So, thank you for that. But white oak, I mean, it's a tree, right? And what is a tree? What is this? Look at this, it's a plant. What is this made out of? Carbon. Who said that? All right. What do I got for you? I know, yeah. Here, you got a soil card. How about that? There you go. Yeah, man. So carbon mostly water, but the physical structure of it is mostly made out of carbon. And where does the carbon come from? Tap room? No, your soil, almost always the answer, from the atmosphere. And most people know that. People believe in carbon dioxide now, so progress has been made. It's invisible, whatever. And so people know, they take in carbon dioxide and they exhale oxygen or something. That's what they think. No, they don't breathe the atmosphere. They eat it. Plants eat carbon dioxide to get the carbon. Bless you. Thank you. They eat the atmosphere, and what they do is they take apart the carbon dioxide, and then they put it together into wood or leaves or roots or flowers and whatever. So they take it apart, and then they put it together, right? And to do that requires energy. How are you going to take something apart and then put it together without doing work? Energy. And where does the energy come from? The sun. Yeah, man. There's a star out there called the sun. It's the only star that has that kind of a name. And it's called the sun. And it shines a tiny little sliver of that. 93 million miles away, there's a nuclear reactor out there that is giving this little bit of UV radiation to the planet. Most of it just goes off into space, but this tiny little sliver of it hits this planet. And plants have figured out a way to use that energy to kick an electron into a higher orbital. When it drops down, it releases a little bit of energy. And that energy can then be used to take something apart and put together something. And that's why plants grow in the summer and not so much in the winter because of the laws of thermodynamics, because it's too cold. But that's what's happening. So this thing is kind of not really exactly correct way of thinking, but in a way of thinking, this is like compressed air or something, I don't know, something kind of like that. And it's also got mineral nutrients and stuff that came from the soil. And in these carbon-to-carbon bonds is the energy of the sun at the time of photosynthesis, is in there. And sooner or later, this thing's going to either burn or it's going to rot, but it's not going to be here forever. It's not going to be here forever. Nothing will be here forever. The sun's going to go out in 4.5 billion years, folks. Do you know that? That's something to get a little upset about. And because it actually will become a red giant and it will be the whole size of the solar system by 1 million times. And everything will melt and then it will go cold out. Oh, I just can't wait. Actually, I am tired. But there in this is the energy of the sun at the time of photosynthesis. A plant that lived in soil is in here, right? That's what this is. And that's all this wood is. Hi, how's it going in there? Great. All right, great. Look at him in there. So, and if you don't believe me, I'll show you a demonstration. Look at here. Do this without the microphone. Look, this is a piece of wood, right? It's actually from Brazil. And this is made from carbon. And it's concentrated from the genetics of this plant that was able to eat the atmosphere and build these carbon-to-carbon bonds. And in these carbon-to-carbon bonds is the energy of the sun at the time of photosynthesis is in here. And if you get this stuff to 451 degrees, which is the temperature at which books burn, Because what is a book? It's just a piece of wood that when you look at, you have a psychedelic experience. But it's just a piece of wood, right? And if you get that to 451 degrees, you overcome the activation energy necessary to shaking the molecules so much that the chemistry happens called oxidation. And the oxidation is the reverse of this reduction chemistry to make this thing with energy input. And now it goes the other way, and the energy comes out, right? The energy, and so in this, if I get this 451 degrees, yeah, come on, Cassidy, make it work for once. Come on. There it is. Now, the chemical reaction is producing its own heat, which is continuous. This is the energy of the sun. There it is. That's the sun. And it's captured, and I can feel it. You can feel the heat. You can see the light, right? And you'll notice that, oh, God. You'll notice that the match is sort of going away. I'm going to blow it out, folks. I got to do it. Ouch. And there's it didn't have complete combustion. And you normally could do this with a piece of paper, and you get this ash, right? And what is the ash? No. Well, the carbon, where does the wood, when you have a fire going in a fireplace, and you throw chunks of wood in there all night, and it just kind of goes away back to the atmosphere. The carbon goes back to CO2, and water vapor and heat comes off, which is the energy of the sun. And what's left over in the fireplace in the morning? Mineral nutrient, the ash, the minerals that were dissolved, that were taken up at the roots, right? And and someday that's all that will be left of you. Whether you do it fast or whether you do it slow, whether you burn it in an abiotic, getting the activation energy up high enough so it gets to 451 degrees so that this chemical reaction goes, that produces its own heat, that continues the reaction until it runs out of fuel, right? I mean, what comes out of the tailpipe of your car? CO2, water vapor, heat, and ash. What is gasoline? Gasoline is just old photosynthetic production. It's energy from the sun. What is coming out of your mouth every time you exhale? CO2, water vapor, and heat. And mineral ash is left over, and that's your body is made out of. That's why you eat food, is to get the food. This thing ate the atmosphere to get and got the energy in it. That's every beat of your heart right now is energy that was captured by sun, that a plant that lived in soil. And if you ate an animal, it's just ate a plant. I mean, it's whatever. Or your mom did. And that's why you're here. And that's what you are. You are soil. You are soil, and you belong. It's all good. It's all one, or none. Anybody know Dr. Bronner's fans? Oh, hell, I'm out. No Dr. Bronner's fan. I want to go work for them. I'm going to quit this gig at some point, man. I would love to go work for them. Anyway, so you see that? See what I mean? And so the same exact chemistry happens when things rot. It's just that they rot. That's that the oxidation chemical reaction, the exact same chemistry happens at a lower temperature. Like inside of you. It's not 451 degrees inside of you. When you eat organic matter, you're crunching up, increasing the surface area, and you're putting it down in your gut. And in your gut are the same bugs that are in the soil. And what are they doing? They're oozing out enzymes, dissolving. And what are enzymes? Enzymes themselves are just made out of minerals, but right, dissolved minerals. But what enzymes do is they're catalysts that lower the activation energy necessary for the oxidation chemical reaction to happen. We call burning, and it releases CO2, water vapor, heat. How do you get a fire to burn hotter? Oxygen, everybody? Oxygen in, CO2, water vapor, heat out. Oxygen in, CO2, water vapor, heat out. And what's left over in the fireplace? And where do those go? Into the bloodstream, and they build your body. Well, that's how it works. And everything else is a sideshow. And it's all about soil and the sun, right? And that's what plants are. And when a plant dies, what does it do? falls down into the soil, and the external metabolism happens. The enzymes, I mean, all the enzymes are produced extracellular in these little microbes. And that's happening inside of your gut right now. And so you eat something or you drink something. Hey, let's drink something. Here's to that. Here's to the soil. Kiss my ass. Sorry. Thank you. Yeah. So, right? Oh my God. No, I don't want to do that. God, I don't want to do that. It's been trying to make me do that for 42 hours. Okay, we'll get to the slides. We will. And it'll be fast because it'll be review, right? Because you can't learn looking at that. You got to tell a story. That's how you teach. That's how you learn. It's a narrative, right? So this happens at a lower temperature, and it's happening in you right now. And so you eat something, goes in here, and there's a bunch of bugs in there, and they ooze out some enzymes, and their populations explode. And in the meantime, you're exhaling CO2, bringing in oxygen, because that needs to happen to make that chemistry happen. And then those populations, it goes to some other part of your gut, and the other part of your gut is a different pH in there, and all the bugs that just got populated, they start to die, and they're starting to go. And there's a whole other population of bugs that eat them. And then their population goes somewhere else. And there's all these different conditions inside of this tube that's going through. That's actually the outside world that's inside, just an inside-out root. What is a root? It's a tube that goes down into the soil and it pulls nutrients in. You flip that inside out, you live around it, and that's what you are. You're just a tube in a tube, you're just a worm. There's a hole here and a hole there, and there's bones and shit, but still, you're just a tube in a tube. And that's what a worm, that's, annelids, that's where we come from, man. And by the time it gets to the end, what is it? Poop. I mean, this is a family show. Thank you. Wow. Hang on a second. That was a good laugh. Wow, man. You go, was that you? That was a hell of a laugh. So that's poop, and what poop mostly is, besides corn and peanuts that you didn't eat or whatever, well enough, is dead microbes. And they just, every step of the way, they get wrung out a little. Nutrients get wrung out just a little bit, using the enzymes to oxidize it. And you're exhaling CO2. Okay, got that? So that's the other side. So there's the abiotic, and this is the biotic side, and so very simplified, but that's what it is. That's how it works. So we'll get to the first slide, shall we? Not that one. It's all about soil. You got that? Thanks for coming. Really, it's been great. Hope you had a good time. Wow, I mean, check it out. There it is, man. All of human history, everything that's happened, all the life on this planet has come and gone in this onion skin thin little film that's a little scum on the surface of the earth. And that's where all this happens. It's amazing, really. And we're here together tonight just to talk about something real. And what I want you to do before your head hits the pillow tonight, I dare you to do this, is to go outside in a private moment alone in the universe and just get down on your hands and knees and pick up a pinch of soil and just say 1 billion. I dare you to do that. Just once. And the other assignment is to say and think about the soil once a day for the rest of your life. That's it. For 1 second, just say soil. I got them done. I did it, Cassidy, And that's it. And if everybody did that, it would be a different world. The problem is people don't know any of that. Most people have no idea why they eat, where they come from, where they're going. No idea. And that's why people are just lost, because they just don't feel like they belong. I swear to God, one time I wore this shirt somewhere, and somebody said, "What's S oil?" We're doomed. We're doomed. Okay? We're not doomed. I don't know, we probably are. But, so anyway, So do that, right? One day, every day, just think the word soil and get down on your hands and knees the night before you go to bed in a private moment in the cosmos and just pick it up and consider the fact of that, okay? That's it. Okay, so let's talk about soil. Now that we know what it is a little bit, let's see. That's soil. It's all about soil. So, look at, there's 20,000 different named soils. 20,000 plus, give or take. It's changing all the time because, people argue about this shit because it's about value. This soil is worth a lot more money than that soil. And when you own this soil, you can do something with it. You can create value, right? And what is this one? So of the 20,000 soil types, they all belong to one of the 12 soil orders. And it's just a taxonomic scheme like any other, except it's better because it can change. It's not like stuck in time. It's designed to be able to change as we learn more. But this one's called an aridisol. What do you think that means? Right. Do rocks dissolve in air? No, they don't. So are there a lot of nutrients being released here? No, there isn't. And so if you want to live in this place, you got to look like that. You have to be highly adapted to live in a place where there's not a lot of nutrients around. In fact, what's the first thing that dissolves out of a rock? And the salt goes down about this deep, and then it stops raining. You know what that is? Salt. Never gets down to the water table because the water table is 750 meters from there. And this is what this is a cross-sectional view, in case you didn't quite see that yet. If you dug a hole and you went there and looked at the wall. And these are called horizons. They're horizontal horizons. And they're created by additions, losses, transformations, and translocations using the chemical reactions of hydration, hydrolysis, carbonation, complexation, and redox reactions that create these differences. And what soil is a four-dimensional complex habitat of a self-organized natural body, a living thing. But what it is it's transformed geologic material that has been transformed chemically, which includes biochemistry, but still transformed geologic. And this has been transformed and translocated salts. And it doesn't rain enough. So this is like a foot deep here. So the soil is this thick. That's it. And all of the life that lives in this environment has to live in a thing this that can only hold that much water and doesn't have that many nutrients, and it's really hot and dry all the time, and there's salt down here. And so that's what it looks like, right? And under here is the rock from which it formed from. And this is the transformed geologic material. There's some organic matter in there from the living and dying and living and dying and living and dying that's happened there. And in fact, they say don't get off the trail, right? Because of the little crust. That's it, because that's all they get. They're like a little biofilm on the surface, and they're adapted to live in these extremely fragile environments. But even here, there's 1 billion organisms in a single pinch. They're just adapted to living here. Now this over here is a mollisol. And mollisols are like this agriculturally important soil. And you see all this is in feet here. So we're talking like 2 feet of this black stuff. And why is it black? That's organic matter. But what mostly organic matter is there for is because of roots that have grown there and then died and grown and injected carbon energy and mineral nutrients. And that just happened over and over and over and over. Now you got this big, and what this is like soil porn. If you're like a farmer, this is power, man. This is like a new truck or something, right? I mean, you try and live there. People do, right? And the reason we are sitting here tonight, just like, try not to swear, hanging out for no good reason, just playing hooky, essentially, is because we live in a place where there's this kind of soil. In fact, under this building is a soil called Willamette, and it's a super nice mollisol. And this is why Corvallis is here. And the reason the university is here is because as far south as you can get by steamship, and they said, let's put the university there, in the heart of the valley, and it's because the steamship, because they could take the agricultural products out of here too, right? And so because it has this kind of soil, here you are. 401ks and cars and probably a little overweight, and you're just gonna just think about things for fun, whatever, just recreational, whatever, because of this soil. Yeah, man. I mean, so that soil. I mean, look at this. Here's the iridisol, right? This over here is a inceptisol. You may say, oh, look, there's some black stuff in there, but look at these rocks. To farm this, you got to dig the rocks out first, and people are doing that right now somewhere. And when you dig these rocks out, there's not much soil left. So 1/3 of the ice-free surface of the planet are these. And that's 1/3, and it's not a great place to have this kind of lifestyle. And that's why this kind of lifestyle is pretty rare, historically and spatially. I mean, here's a map of the global soil regions of the planet. And look, in this scheme, the mollisols are green, okay? And 21% of the United States land mass is mollisols, right? And worldwide, 7%. That's all you need to know about why you are fat and happy. Because there's agriculture. And the agricultural revolution begat the industrial revolution, which begat the information society revolution. I guess I'm right, man. I mean, even electronic dance music is all about soil. It is, because I was in a band, and it was electronic dance music, and talk about frivolity. That's just like fluff on the top of the industrial revolution, just to be an artist and still be able to have fun. Wow. And I don't know if you can see on this map of the planet Earth, which is actually a map of political power. Yeah. They who have the mollisols have the thermonuclear weapons. I don't know if you can see the other places on the planet that have as much mollisols as we do. Anyone see that? Yeah, man. What do you think? This is Russia, maybe.
Yeah.
And here, what is this right here? Ukraine. Some of the most fertile soils on the planet are right there. What do you think they want to put the big bear back together for? Agriculture, right? Get rid of the people. Hey, it's been done before. Hello. Why are you here? Okay. It's an ugly little world, that's why. And so, we don't need to make any proclamations. The facts are clear. We got this land the same old-fashioned way. But from this agriculture came industrial revolution. From that came science, and from that came thermonuclear weapons. And you control the planet because you have the power, the literal power of the sun, captured in carbon-to-carbon bonds from photosynthesis in living plants that lived in soil. All right, see what I'm saying? So, and look at where the troubled spot. Here's iridisols. Right? Where are the inceptisols? They're kind of up in here, but there's also, these are the frozen soils up here. See these little brown things? Those are all organic matter. Those are peat bogs. They're like the soil, the parent material there is organic matter. Because it's sunny enough and warm enough that moss grows, but it's cold enough and wet enough that it doesn't really decompose. That's how a refrigerator works, right? You put it in there and it stays cold, so the laws of thermodynamics don't allow the chemistry to happen, biochemistry to happen, for it to rot. And so it pickles and it becomes peat moss. And that's where, if you've ever, got a bag of soil media or whatever they call it, it's not soil. It's potting medium, thank you. And it's mined from these sites. And it's going away. And you'll notice that, see the frozen soils up here? You'll notice that the peat bogs sort of end where the freezing happens. You know what this mostly is? Peat bogs that are frozen. Yeah, man. And you know what happens when they warm up? The CO2 goes out. And the bug, for every 10 degrees increase in temperature, soil temperature, is a doubling of biological activity. If we doubled our biological activity in this room, what do you think the CO2 level would happen? Would it get warmer in here? Yeah, it would. It would get CO2 go up, the oxygen would go down. It probably start to smell pretty bad after a while, because the bugs that live in every hair follicle. Every hair follicle has this little critter that lives down there with its head down. It comes up at night and eats like dead skin cells, and it poops on the surface of your skin, and that's why you stink. Yeah. Yeah, man. You're never alone. You can't do that. You will never be alone. They're going to eat you from the inside out. They're waiting for you to die. Is this fucker dead yet? Anyway. And you might be thinking, oh, like, the tropics, aren't those great soils? Not really. You know why? Super wet, super hot. Where are all the nutrients in this part? They're in the living above, they're in the cycling in the above ground biomass. That's why the tropics look the way they do. Because the soils are really poor. And they're really old, so where did all the nutrients go that were in those soils? In the ocean and became sharks. And at different times in history of the earth, these were in different positions, and so they adapted to living in really nutrient-poor soils, and that's why the tropics are just the way they are. I mean, the minute a leaf falls in the tropics, before it hits the ground, it's being ripped apart by an ant. Before the ant goes to sleep, it's being eaten by something else, which shits it out right on the roots of the plant that are above the soil, and they're just taking it. It goes right back into the tree, and as you go higher latitudes, the soil, the cycling of nutrients goes deeper into the soil until finally it's recycling below ground all of it, and that's what this peat moss is, right? You kind of get that? I don't know. Kind of interesting. So what this is a map of, and you should show this to your elected officials and say, what is this a map of, without putting this on here? And if they don't say political power or soil, they have no business having political power because they don't even know where it comes from. And this is where it really comes from. And invention. I mean, it's not just all soil, but that inventiveness has allowed people to live in places that don't have great soil too. But still. All right, you got that? All right. Here's an oxisol. So these are the tropical soils. Who's been to the tropics? Look at us, we all flew in tubes there and had drinks and shit at 33,000 feet. God, really? Wow. And we did that because we have an advanced industrial country that we can do that. But this is what an oxisol looks like. It's like really red because you know what's left over after all the rocks have dissolved away? The most abundant elements in the Earth's crust, you know what it is? Iron. And it becomes iron oxide, which is this very stable thing, which is why barns are painted red, because you mix that with oil and you put it on wood and it seals it, and when it dries, it's got iron oxide on it, which doesn't dissolve in water, and now it's protected from moisture, and so the bugs can't put their enzymes onto it to rot it, and that's why you paint stuff, and that's why red is very, abundant, right? Anyway, this is from Hawaii. It's called Molokai. So there's different named soils. Like the one under this building is called Willamette. Guess why? And this is actually the taxonomic name for this soil, which is a very fine kaolinitic isohyperthermic torox. Come on, let's all do it together, because you got to do this once before you can do it twice. Okay, you ready? We're going to do it together. Very fine kaolinitic isohyperthermic typic eutorox. It ends in ox, so what is it? It's an oxisol. Now you learned something there, right? And all of the 12 soils, you look at this big gobbledygook word, 20,000 of them, and you can tell what soil order they belong to by looking at the last 2 or 3 letters. And so you read this backwards, of course, because it's soil. And tor means hot all the time. And eutro means all the time. And typic, it's a typical one. And isohyperthermic means it's hot all the time and dry. So this is a hot all the time, typical hot all the time oxisol. And it has kaolinite clay in it, which is a special kind of clay that doesn't have a lot of cation exchange capacity. It's a 1-to-1 clay, you might recall. It has a little edge charge, you might recall. Yeah, yeah. And it's very fine, meaning it's like very fine texture, what that means. So now you can just read this word backwards and you learn what the soil is, and that's how they make this language up. It's a secret language of soil science. I'm not going to show you. Look here's Oregon. In Oregon, we have 10 of the 12 soil orders. It's the most diverse state in the country in that regard. And that's why it's such a great place to study soil, because, I mean, my God, this is uplifted marine sediments here with intrusions of ancient Columbia River basalts. You ever go to the ocean, you see those big basalts just going out into the ocean? Those were rivers that got filled with basalt. Imagine being a fish and those basalts coming down all of a sudden. Swim. And then it cast the river, and then the whole thing got uplifted and all the sandstone washed away. And that's what that is. And then this is, volcanism that caused by a plate out here slipping under the continental plate, causing friction and blah, blah, blah. Now there's got volcanoes here, special kind, these are andesols. And then there's a valley in between where the largest floods ever known to happen on the planet Earth happened here, right here. It came down the Columbia Gorge. You know why I call it a gorge? Because it was gorged out by 500 cubic miles of water moving at 100 miles an hour with the consistency of wet cement with boulders the size of this building in suspension. Came down the gorge and overtopped the gorge by 100 feet. Like Hood River and shit, you see that? Imagine that all full moving at 80 miles an hour. And all that came from these sediments up here because of the last ice age. And I'd love to tell you the whole story, but we got to get out there and pinch some soil at some point.
Is that the Missoula flood?
Huh? The Missoula floods, which the ice dam, 2 miles thick glacier blocked off the Clark Fork River, which is about the size of the Lamb River or something like that. And it blocked off, and it was 2 miles high. And so for 5,000 years, the water built up behind it to the 500 cubic miles of water, the size of the largest freshwater lake in the world, depending on how you count, Lake Superior behind it. And then it all catastrophically failed in one instant, and 500 cubic miles of water came out of that drainage in 24 to 48 hours, gone. And as it came along, it just scoured the soil down to the bedrock, and then it pounded the bedrock 400 feet, just pounded to dust. And then it came down, and it went down the gorge, and most of it hit this really hard piece of rock here and actually deflected it, turned the river north. And then out here, 60 to 600 miles out here, is cobble that came from British Columbia that was pushed down by ice sheets and traveled that whole distance. And a little bit of it turned south right here, and it filled up this Willamette Valley to 200-foot elevation. Took about a week for it to get to 200 foot. I mean, you couldn't get out of here fast enough because it'd be coming up like a foot an hour, and you're done, right? It's going to happen again. Don't worry, there'll be another ice age. I mean, hello, we can predict it actually. It's coming. Milankovitch cycles and all that jazz, right? The tilt and all that, right? Never mind. And so what this is a lake floor. So there was a big mountain range in here and mountain range here, and there was a deep valley, and there was some river down in there a long time ago. And then this giant flood came in and just frosted it in. Just frosted it over with ground up basalt, which is dark colored minerals. And dark colored minerals have the precursors for biological organisms, and the dark basalt is the best kind of rock for making fertile soil. And that's why the color scheme is different here, but these are mollisols on the floor here. So imagine we're at about 200-foot elevation right here. So imagine 200 feet over us, water, the entire Willamette Valley. But there are some islands up here in the Eola Hills and stuff like that, and that's those kinds of soils. They're altisols and oxasols. They're good for, not oxasols, but altisols, which are good for growing grapes because they're nutrient poor, and the stress on the plant is what makes it make better tasting grapes so that a bird will eat it and shit the genetics out somewhere else so that the plant can be happy. And that's why we put them on the hills, is to stress them out, to make them express those genes to make delicious wine and stuff like that. So yeah, what about, and this is all desert out here. God, Fort Rock out here. You ever been out this way? Unbelievable, man. And this is dry, so a lot of iridosols and stuff like that. Here's spotosols on the coast. So this is out here. What this is in the last ice age, the ocean was much lower elevation, so the continental plate was dry out there, and all the sand blew around, these giant, the sand dunes and the dunes, right? But the whole thing was like that. 500-foot dunes or 1,000-foot dunes of this stuff. And then it all sat there, and then stuff lived and died, lived and died, lived and died in it. And the kind of products that are the biochemistry produce strong acids that leach out iron and aluminum, which then precipitate down here. And so this is aluminum oxides and iron oxides that came from this biological process, and a lot of water moving. And that's called a spotosol. And these are the most charismatic of the soil orders. People come from all over the world to go look at these things, just because they're beautiful. I mean, I gotta tell you a little secret. The sun sets every day. You don't have to watch it. It's not, I mean, big deal. It looks exactly the same, goes down. Go to the coast, and when the sun is set and everybody's looking at it, just turn around and just watch the sun set on a spotosol. Because there's different frequencies in the electromagnetic spectrum. You'll see different colors, and there's actually even some fluorescent compounds in these that you can see if you're like really looking. But for real. And andisols, and this entisols, it's just sand, right? And this is inceptisols. And look at, this is real soil. Real soil doesn't come in a bag. Forms over time from dissolved minerals and reprecipitated and secondary minerals, and that's what soil is. And then living and dying. See this little crack here? That was once a root. A tiny little root hair went in there, and then it got bigger using carbon, and it pushed the soil apart using the energy of the sun to do that, and then it died and it went away. Back to CO2, water, vapor, heat, left a little ash behind. And now this crack is here forever until something else breaks it up. And so this is a larger pore, which water can drain from large pores, and water is stored against the force of gravity in the small pores. And so this will be recolonized by another root, which will eventually go deeper, and pretty soon the soil becomes modified by the plants to become better habitat, and the genetics of the roots are expressed based on the texture of the soil and the water and the temperature. And so some plants can change the way they grow roots to make better habitat based on the habitat conditions. And so soil is formed by plants. And the plants that didn't form better habitat didn't pass their genes on. The ones that did, and that's why there's different kinds of plants in different places in the world. Because they're adapted to soil conditions below ground. And large pores drain under the force of gravity. When they drain, think about a raindrop going down a root channel by gravity. What's being sucked in behind it? Air. And so when the soil is draining, the soil is breathing. And these critters, they need oxygen. And how do they get it? By drainage in soils. And plants breathe oxygen at their roots. You know when plants need oxygen at their roots? All the time. You know when plants need water stored in the small pores? All the time. And that's why you want a wide pore size distribution, which is made by nature, by the plants make a wide pore size distribution and sculpt the soil to drain and hold water. Yeah? It's all about soil. And then they just leave this thing behind. Isn't that amazing? This is clay films here, secondary minerals, and blah, blah, blah. Bottom line, soil is habitat. If you get nothing else out of this talk tonight, if you can just conceptualize the reality, the fact that soil is the habitat on the planet Earth, and from that came all of this. And all the biochemical reactions in your body right now were invented by organisms trying to live in this environment, right? You know that? All right, just look at this picture, right? So here's a 0.5 millimeter by 1 millimeter. A little piece of soil, I don't know, maybe like that big. And if you look at it, see, here's a piece of sand. Here's a piece of silt, which is a small rock. Here's a piece of clay. And here's a body of water. I mean, I don't know if you've ever noticed this, but when you make a small pore, a little bridge of water is held there, right? Against the force of gravity. Small pores hold water against the force of gravity. Large pores drain into the force of gravity, right? Look, here's a small pore between 3 pieces of sand this one's made from basalt. This is a piece of silicon dioxide, and this is like some jasper or some sort of metamorphic rock, and they're all dissolving into this sea of water here, nutrients. And there's a giant sea serpent living in there. And this thing, they're trying to eat that thing, and this thing trying to be the poop of that thing, and this thing's waiting for this to die so they can eat it. So this is an ecosystem happening between 3 pieces of sand. And look at this big pore here that's filled with air. How do you think that got made? How did that rock get pushed apart? An old root. Oh my God. All right. Did you say root? Yeah, man. Yeah, you did. All right. Such a dear one.
Thank you, dear.
Yeah, man. Love you. You know that. And so there was a root there that pushed these apart and then it watered away. And now there's a drainage area there. And look at this ciliated protozoa living here. And look at this up here. There's a root that's leaking sugar water into a completely different pH, different chemical environment here than that. And these are each individual microhabitats. Down here, there's some bacteria that reproduce every 21 minutes. And they're uniquely adapted to this environment in the entire universe, for all we know. I mean, this is it changes. In the winter, this all gets wet, right? And the first place to drain is this one. So the oxygenated water is here, not here, right? You're saying that? It's all different. And look at this thing. This is like the lion in the Serengeti. And it breathes air. And there are bacteria that are unique that live in the hair follicle roots of this thing. And nobody thinks about this thing. And it might be the keystone species to this entire environment. And it manages the populations, for all we know. In fact, there's people who study this thing, probably. There's like 5 guys in the world, and they go have drinks at the international whatever meeting every year, and they look at each other's paper, and they, try and pull students through or whatever. Look at that, right? So that's what I mean by diversity of habitat. A cubic millimeter of ocean water is the same wetness wherever you are in it, same temperature, same chemistry, probably the same organisms in there, not too many of them, right? This is like, just vastly more complex. All right. So, soil is a living thing. It's not a chemical sponge. In the 20th century, we got good at chemistry, and we thought it was a chemical sponge because we couldn't see this stuff, right? And the people who could see it were laughed at the university. And so, real quick review, and then we'll kind of wrap it up. Soil is rotted rock and decomposed organic matter, but it's also air and water, right? And this is the pore space. It's about half of this is space. And you're not really gardening, you're ranching microbes. You're not really even ranching microbes, you're space managing. And you're trying to have small pores that hold water and large pores that drain in about equal proportions. And that's what a loam is about equal percent sand, silt, and clay. So it has equal percent sand, silt, and clay-sized pores. And sand-sized pores drain, and clay-sized pores hold water against the force of gravity. And that's why this Willamette silt loam that we're sitting on top of right now is why you're here, And then the rest of it's mostly minerals of different sizes. Sand is anything from 2 millimeters down to 0.05 millimeters. Silt is anything from 0.05 millimeters down to 0.002 millimeters. Anything smaller than 0.002 millimeters is called clay, according to the USDA size class particles. And then there's this little slice called organic matter, which 5% is a lot. If you have 5% organic matter, that's a lot of energy and carbon. And you can grow anything if you have that. And this is transient, though. It goes away because it burns, either either oxidative reaction, either abiotic or biotic. Look, here's a piece of rock. Zoom in on it. Look at different crystals made from different elements. Some of these dissolve faster. The dark ones actually dissolve first. And those are the ones that have super important mineral nutrients for life. And eventually the red ones fall out, and pretty soon there's left these little white ones, and those are the sand. If you want to see ancient mountain ranges that no longer exist because they've come and gone 3 times, go to the ocean. Watch the sun set on a spot of salt. Before you do that, taste the salts and lift up the skeletons of ancient mountain ranges and just participate in reality once a day. Just say the word soil. And you'll be participating in the great ritual of all life on the planet. Just do that, all right? And so these things dissolve away. And this is a piece of sand, 2 millimeters down to 0.05 millimeters. It's just a rock. Silt is just 0.05 millimeters down to 0.002 millimeters. It's just a rock, ground down, dissolved down into a sphere, which is the minimum surface area per unit of volume because that's how it dissolves. And then see this? Clay is small. This is 50 times bigger than this. I mean, this is 50 times too big relative to these sizes. This is the smallest pixel I can make of the screen. And clay is a different thing. It's not just a smaller rock. You can't handle the truth. Just kidding. There you go. Oh, thanks. Clay, and we'll wrap this up real quick. Clay is a tiny, tiny particle, 0.002 millimeters or smaller, because what clay is when rocks dissolve at the surface of the earth, because they're most stable at high temperatures and high pressures. You bring them up here and it's wet, and they start to dissolve. And then they recrystallize into secondary minerals like oxides and clays. And the clays are the crystal. Imagine a crystal growing, and it can only get to 0.002 millimeters, and then it breaks, because it just isn't structurally strong enough to be any bigger. And the clay is also layers. There's sheets of these that stack up by the millions, and they can only stack up to 0.002 millimeters before they sort of fall apart. And so clay is a different thing, and it's the reason you're here, and I mean the reason you're alive as a macroorganism. You could be a microorganism and live on this planet if there wasn't clay, but there's no way it could be a macroorganism, because clay does something that nothing else except organic matter can do, and that is store nutrients. This is just a rock. There's no charge on this thing. This is just a smaller rock, and it's got a small surface area. This thing is a giant surface area, and it's really small, and it has a negative charge on it that can store positively charged nutrients in sufficient quantity for there to be macroorganisms on the planet, like plants, and then everything else that flowed from that. So clay is a secondary mineral that forms at normal surface temperatures and normal surface pressures, and is the product of dissolution and recrystallization of primary minerals. Okay? And without that, man, I'm telling you, there wouldn't be life. And not all rocks can have the constituents to make clay. So some rocks don't have the inherent possibility of making clay. And that's why they look like iridosols and stuff like that. And how do you make clay? You got to have water. So you think there's a lot of clays in iridosols? No. So is there a lot of nutrient storage capacity in those? No. And that's why it's like that. And that's why, you know, in different parts of the world, people are starving to death. Because this just doesn't have they don't have the agriculture. Look, here's a review. Primary minerals dissolve in water. Look what comes out of them. Nutrients, right? And then some of those nutrients recrystallize into sheets of silicon aluminum oxide called clay. And oh yeah, you thought this wasn't going to be school. You thought this was going to be fun? Lock the door. Because we're going in. All right? This is what dissolves out of a rock. The four most abundant elements in the Earth's crust. Do you know what they are? Four most abundant elements in the Earth's crust: silicon, iron, aluminum, and oxygen. Rocks are mostly made out of oxygen. Sorry, where do you think it came from? And silicon has a certain size and a certain charge that forms a covalent bonds with these oxygens and creates a silica tetrahedron, right? Because of the size and charge of this element, it can form these bonds. And this is the crystalline building block of the tinker toy called clay. And similarly, aluminum has a certain size and a certain charge to form covalent bonds with 6 oxygens, or in this case, hydroxyl groups, but still oxygens. And they can share these oxygens, and that's the building of this crystal atom by atom as the rock dissolves, as long as there's the proportions of these things are in this proportion. Okay, so look, there's a silica tetrahedral sheet, there's an aluminum octahedral sheet, there's a silica tetrahedral sheet, this is the layer, there's a million of them. Here's the growing edge where the next one comes down and it builds until it gets to 0.002 million and it breaks, right? Look at it, here it is, right? But I promise, just a little more of your time, because this is the reason you're alive. So let's have a drink. To clay. And the Marys River Watershed Council. Yeah. As it turns out, there are some elements that have almost the same size and almost the same charge as silicon, and some rocks have that too, like dark-colored rocks, like basalt. So instead of silicon, iron. Iron has almost the same size and almost the same charge, and it fits into this ordination. And also magnesium, which in dark-colored rocks have almost the same size and almost the same charge as the aluminum, but not quite. And so the crystal forms with these little impurities in it, which result in a net negative charge being propagated onto the surface. A thimbleful of sand has a surface area of a sheet of paper. A thimbleful of silt has a surface area of a large newspaper spread out. A thimbleful of clay has a surface area of a football field. And if it has isomorphic substitution in the secondary mineral called clay, it has net negative charges all over that surface. You know what sticks to negatively charged things? Positively charged nutrients. Instead of being washed down into the water and becoming sharks, they're stored on the surfaces of clay. And they're just stored there. And they don't wash away when it rains because of this electrostatic charge that is on the surface of this high surface area thing. Hang in there, we're almost done. I know you're trying to escape. You can escape if you want to. We'll just ridicule you. All right. So here it is. All right. This is called isomorphic substitution, which is a source of negative charge on soil. Look at 100,000 times magnification of clay. Okay? This is not a ground down piece of rock. This is a secondary mineral that built up atom by atom and has an enormous surface area and has net negative charges all over those surfaces. And that's what cation exchange capacity is. That's what gives soil a value. The higher the amount of negative charges, the more nutrients it can store. And that's what a mollisol is. And if you have a mollisol, you can have thermonuclear weapons and enjoy the good life for a while. I'm just saying, if you want to be an evil son of a bitch, I guess is what you could say. Right? You can't help it. 100,000, look at this one. Look at the surface area of that. Net negative charges all over due to isomorphic substitution, second mineral called clay. Look at this one. Look at the pore space. It's like 90% space. And it has net negative charges all over due to isomorphic substitution. And second mineral called clay. Look at this one. Net negative charges due to isomorphic substitution. Second mineral called net negative charges due to isomorphic substitution. Look at this one. Net negative charges due to isomorphic substitution. And second mineral called clay built up atom by atom at the surface of the earth at normal surface temperatures and normal surface pressures. It's a secondary mineral. So everyone together, ready? Let's say it. 1, 2, 3. Net negative charge due to isomorphic substitution on the secondary mineral called clay is the reason you're alive. All right?
Praise the clay.
Yeah, man. Praise the clay. And people bitch about clay around here. Try it. You'd really bitch if you didn't have it. You would. So I'm just saying, you're lucky to have it, right? Look, here's clay. Look at, you can kind of see it now. Look at calcium. Every atom of calcium in your secondary mineral that was formed inside of your body as a skeleton, in the shape of a skeleton, based on DNA, which itself is made from minerals, was once stuck on the negative exchange complex of clay. And it will be again, pretty soon. And it's almost over, folks, and I mean this talk. Okay? Look at this one. Here's some clay. Look at nutrients, fertilizer. That's why you fertilize. You want to fertilize so you have the stored nutrients in the proportions that you want to grow the crop that you want to grow. Right? That's what agriculture is. Oh, yeah, look at this. Okay, so last thing. Turns out there's one other thing in soil. There's one other thing in soil that has almost the same, has twice the nutrient, the negative charge as the best clay. Guess what that is? Organic matter itself has cation exchange capacity. Like double that of the best clay. Because you may think, oh, I got shitty soil, I got sandy soil, maybe I should go get some clay. From whose dead cold hands are you going to get it, number one? And it's actually just easier to kill the people, as you know. And that's what we do. Or you could grow organic matter. It's all good. With sun and the plants eating the atmosphere and increasing the cation exchange capacity and improving the soil. Right? All right, this little bit here, look at that. Here it is. Oh, we're going to skip all that and this and that and the other thing. But here's what this is organic matter, a random molecule that doesn't reflect back any particular light in the electromagnetic spectrum. So that's why it's black, because it absorbs energy and it warms up. And the laws of thermodynamics, dark soils warm up faster, so everything happens faster in dark soils. You want to know what the answer is?
Yes.
Doesn't matter what the question is.
Add organic.
Yeah, man. The answer is add organic matter. Because when you're adding organic matter, you're adding carbon, you're adding energy, and you're heating up the soil, and it can hold 80 times its own weight in water in the available pressure range for plants to access. Right? And the more plants that can live there, the more organic matter accumulates. And the more organic matter accumulates, the more plants can grow there. And the more plants that can grow there, the more energy comes from the sun and that's what soil building is, and that's why there is soil, and that's why you're alive, because that happened. Because of the laws of thermodynamics and physics. And you're just like this weird outcome from that. And look, there's net negative charges all over this high surface area thing. And that's organic matter. Look at this. Here's the roots of a plant. Look, here's the root hair. It's so small you never saw it before because it's microscopic. Look, it's in the small pores. What's in the small pores? Air or water? Water. And look, here's soil. Look, it's got a negative charge on it. Where did the negative charge come from? From isomorphic substitution, a second mineral called clay, and organic matter. And look what's stuck to it. Nutrients that aren't washing away. It's stored there for the plant, and when it's warm out, the plant breathes a little harder, and CO2 is exhaled into the water, which acidifies the water, and the hydrogen ion actually substitutes out the nutrients, and the nutrients flow into the plant, and then you eat it, and that's why there's a skeleton in you. And that's how the plants get the nutrients. And then they die, and they're taken apart, and the nutrients go back onto the negative exchange complex of clay and organic matter, as has happened billions of times already before you were here to make you. Yeah, man. Check it out, right? This is what all these nutrients do in plants. You eat them, and they do almost the same things in you. And then we all die. And this talk is actually almost over. And so is your life, so have a great one. And we're starting off good here. And I just got to say one more thing. I do sell these shirts to fund the internship program at the student farm, because we received no funding from the university. Just saying. 24 years, we created the wealth from the ground to pay the interns to keep the farm going. And we are now officially a nonprofit. Yeah, man. And you can buy these shirts. Go to soilforward.org, won't you? And support the next generation of students who want to know about how the world works and maybe even become farmers. And man, I mean, it's super important work. And they're great students, and they would love if you would buy a t-shirt. But I also have them in Klingon and in Vulcan. So have them there, and I think we should just call it. What do you say? Yeah? All right. That's good. All right, that was fun. And here's a card for you. Here's a card for you. Oh, yeah. Yeah, man. And don't anybody ask me about biochar, or I'm leaving. Just kidding.